Hello, Sean Walia here, ready for another math video. Today we're going to be talking about rational expressions. What is a rational expression and what are non-permissible values? So let's get to it. So a rational expression is loosely defined as a polynomial over a polynomial. But what's a polynomial? A polynomial is any number of terms. For example, I could have 3x squared plus 2x minus 5. This is an example of a trinomial. You'll notice that this polynomial is of degree 2 because that is the highest power of the exponent. We could have another example, something like 3x minus 5. This is another example of a polynomial of degree 1. Now, of course, to be a polynomial, when you look at the variables, typically the polynomials we work with are in one variable to varying powers. These powers must be whole numbers. So you couldn't have something like this, 5x to the negative 3 plus 2x squared minus 9, and call that a polynomial expression because we have a negative value or an integral value as an exponent. That's a no-no, okay? So we can't have that. No, not a polynomial. You can do this as long as you like. You can make up polynomials 5x cubed plus 2x to the 4th minus 6x minus 10. Someone would correct me about this polynomial because I didn't put that in the correct order. Typically, we want to put them with the highest powered variable in the front. And you will see later why that is. Okay, so that's about it. That's what a polynomial is. Remember, we're talking about rational expressions, not polynomials. A rational expression is a polynomial over a polynomial. So an example would be something like 2x minus 3 over 2x squared minus 3x plus 5. Another example would be 2x squared minus 3y plus 10 over, I'm not very creative with my numbers today, minus 5x cubed plus 2x. Okay, so I mean, you should have a good understanding of what a rational expression is. Just keep in mind that the exponents have to be whole numbers. You can't see any variables. You couldn't see an a to a root, perhaps, because that's a to the 1/2 not being a whole number, or anything else. Other than that, you couldn't see any variables to a negative exponent, right? Because that, of course, is 1 over x to the 4th. And that is not going to work inside a rational expression. It's not polynomial. All right, so now that you have a good idea of what a rational expression is, we're going to talk about non-permissible values. So non-permissible values, you don't have permission to use these values. Now, what exactly does that mean? You should have learned at some point that in mathematics, we're not allowed to divide by 0. It's what we call undefined. It doesn't work. So when we have expressions, we have to consider the possibility that we would be dividing by 0 and just exclude it, make sure it doesn't happen. So an example would be something like if I gave you a rational expression like x plus 2 over x minus 3, and I asked you what the non-permissible values were. There's different ways to ask this question, by the way. I could say, what are the non-permissible values? And you would say, you know, x would be 3. X can't equal 3. Now, where did I get that from? Well, we just talked about how you can't divide by 0. Notice if I substitute in 3 for x, I'm going to get 3 plus 2 over 3 minus 3, or 5 over 0, which of course is undefined. So x can't equal 3 for this expression. Now, if you want a procedure to figure out what x can't equal, what you can do is you can set the denominator to 0. Okay, so set denominator to 0 and solve equation. Okay, so what would an example like that look like? Okay, so for example, let's say I had example 1, 3 over 2x. Okay, so I would grab the denominator and I would say, you know what, that denominator there, it can't equal 0. Okay, well, how can I solve this equation? A number is being multiplied by some number. 2 is being multiplied by some number. The opposite is division. I'm going to divide both sides by 2, do a little bit of algebra. And you see here x can't equal 0. If you substitute 0 back into the expression, you'll see that you're dividing by 0, and you've discovered the non-permissible value. It's very exciting, I know. Here's another expression. Say if x minus 3 over x plus 5. Okay, same thing. We can start by saying, in some of these you'll just be able to look at it and you'll be, okay, x can't equal this. But I'll do the procedure for everyone's benefit. X plus 5 can't equal 0. Doing the algebra, I'll minus 5 from both sides. X can't equal negative 5. Substitute negative 5 back in there. You'll see you'll be dividing by 0, and that, of course, can't happen. So, let's do one more example, okay? So let's say we had 3x over 2x minus 3. So perhaps the answer to this is not as obvious as the previous examples because they were just whole number or integral examples, excuse me. This one is going to turn out to be a rational number. So if we follow that procedure, though, where we just take the denominator, we say 2x minus 3 can't equal 0. And then we isolate x. So I'm going to add 3 to both sides, leaving me with 2x can't equal 3, and then dividing both sides by 2, and x can't equal 3 over 2. Okay, so boom, right? There's your non-permissible value for this example right here. Now, all the examples I've done thus far have actually been, the denominators have been linear, meaning degree 1. If we move into degree 2, which is most likely what you'd find in a pre-calculus class, degree 3 is very untypical. But I will show you degree 3 as well. Let's take up something like 5x minus 3 over 2x squared minus 8x. So now you're seeing the denominator is a quadratic expression. It's no longer linear. And when we have to solve equations like that, we don't isolate x. We have to go through the methods of solving quadratic equations. That's a whole other video. So you should have learned that by now. The technique's factoring, though. I'm sure you know it. So basically, we do the same thing I said before. 2x squared minus 8x can't equal 0. But then how do you solve this equation? Okay, well, it's a quadratic. Bring it all over to one side and factor. The type of factoring that we're going to do here is common factoring. I'm going to take out 2x and multiply that by x minus 4. Can't equal 0. And hopefully you know your quadratics, you know how to solve them. And at this point, when you have a factored quadratic, you know that the solutions here, x can't equal 0. We get that from this component of the expression. And it cannot equal 4, which we're getting from this component here. So there it is for this particular expression, x can't equal 0 or 4. And if you substitute those values in for x, I can do that for you if you like. If I substitute that back in for x, just to check, okay, so this is like, I've answered the question, what are the restrictions? What are the non-permissible values? I've told you. But if I want to make sure that I made the correct calculation, there it is. If you simplify the denominator there, you'll be dividing by 0, and that's a big no-no, right? No dividing by 0. So that's one example. Another example, I guess the first example, I don't even know. The second example first example of a quadratic, boom, in the denominator. Let's do one more, okay? Let's do something like, let's go 6 open bracket, a plus 2 over a squared minus 2a minus 8. Okay, so again, same strategy. I'm going to take, okay, so again, what's the question? What are the non-permissible values? So we'll take the denominator. We'll say a squared minus 2a minus 8 can't equal 0. And we'll factor, just like we did before. The only difference is this is trinomial factoring, where we take the factors of the constant and find those factors that subtract to make -2. Again, solving quadratic equations is a whole other video. You got to check that out. Be sure to check out Sean Walia Math, and definitely like this video if you're enjoying what I'm doing right now. This is actually my first video, and I'm really excited about it, and really excited to give more content and help more people with mathematics, because that's what my life's about, yo. Here we go. So yeah, there it is. A can't equal 4 and -2. Again, if you substitute back in there, you'll be dividing by 0. You silly, silly goose, you. I think that's all I really have to say about what a rational expression is or isn't, and what to do with non-permissible values. I mean, I can show you something a little bit more sophisticated. I won't show you how I got there, but I'll show you how I could have something like x minus 3, x minus 6, and then on the bottom, x plus 2, x minus 3, and x plus 5. Now, I'm going to do another video on simplifying rational expressions, and maybe you guys know if you have the same thing on top, like so, you can cross it out because anything over itself is equal to 1. However, you have to consider the non-permissible values before the cancellation, okay? And again, I didn't show you how I factored the denominator here, because that's factoring a cubic equation, and that's a whole other lesson, okay? For now, though, if you say x plus 2, x minus 3, x plus 5, and once again, the main reason I'm doing this equation or expression is to show you that it doesn't matter that these cancel. Like this simplified expression, yes, these will cancel, and I'll have x minus 6 over x plus 2 times x plus 5. Okay, yeah, it cancels to that. I love it. But you still have to check the non-permissible values before the cancellation, before you do anything, any manipulation whatsoever. And that goes for any expression in mathematics, okay? You want to make sure you consider what x or the variable cannot be before you proceed further, okay? Okay, so in this example here, x cannot equal -2, 3, and -5, okay? I'll do one more example. Just because I want to show one more type of trinomial that could show up, and I'll make this one as quick as possible. So on the bottom, I've got 6x squared minus 7x and minus 5. Okay, so we'll do this one like we've been doing all the others. We'll start by taking the denominator and saying that it can't equal 0, and then recognizing, what am I looking at? It's a quadratic equation. Why? It's degree 2. All right, okay, so how do we solve that? We do it by factoring, and my technique is trial and error. There's lots of different techniques, so you're going to watch me try this out. Okay, so I'm going to consider factors of 6. I'm going to try 2 and 3, and I'm going to consider factors of 5 and, I don't know, maybe 1 and 5. And then what I'll do is I'll check to see, well, what do I get when I times these two together? I get 10. What do I get when I times these two together? I get 3. Do these numbers have the ability to subtract to make 7? And yes, they do. In fact, if I go minus 10 plus 3, you're going to get that -7 that you're looking for. I'll put in the variables now because I'm pretty sure of my choice, and just kind of clean this up a bit. I don't need that stuff anymore, and there I am. So from here, this is a little bit more sophisticated. From here, you might want to split this up to two different equations. 2x plus 1 can't equal 0, and 3x minus 5 can't equal 0, and solve each one of these independently. So you have 2x can't equal -1, divide both sides by 2, x can't equal -1 over 2, And then 3x cannot equal 5. I'm probably, I'm not showing my work here. I'm a bad math teacher. Very bad. Okay, there we go. Boom. Divide both sides by 3. X cannot equal 5 over 3. And again, if you substitute those values back into the denominator here, again, you'll see we'll be getting 0. You can't let that happen. And I think I've done a pretty good explanation of non-permissible values and what rational expressions are. I hope you liked it. Yeah, please subscribe to my channel if you want more math lessons. And yeah, welcome to my channel. It's my first video. I'm really excited to be here. Thanks a lot.